Hello?
Look at those palm trees. Damn.
So, once again, my name is Sebera Bananu, and in this session, I'm going to be reporting the changes that they were made to they were made in Apache Pulsar transaction. What happened was that in version 2.70, they actually released transaction as a preview version. So in the latest release, it's now put ready. So what I'm going to try to do live here is trying to see if there's any differences between their own implementation and the implementation that I did in SharpPulsar. We are going to be looking at it too. If there's any changes, then we port it over to SharpPulsar. So let's take a ride together. So I chose to live stream today on YouTube because I discovered that on Twitch the video gets deleted after 14 days. That is for normal users, and after 60 days for prime users. So one thing is, except if I do a clip of the video, I like the video, then it can be stored forever. But on YouTube, I think it gets stored forever. So why will I want to do a live stream that after 14 days? It's more like an audit. Like, how can I audit where I was coming from and where I am right now? So I just want my video to be stored forever, so that in the future I can always go back to it and say, wow, these are got started on streaming on YouTube, on Twitch. So from going forward, I'm gonna be all my live stream will be done on YouTube because of that particular reason of forever storage. That is being able to store my video for life. So that's why I'm going to be streaming on YouTube now, because I cannot stream on Twitch when I know that this video won't outlive me rather. So I want to do a video that will outlive me. So just a moment, I need to get something set up on my workstation.
Empty streets, but I keep searching for your trace in the dark. Losing myself in the endless memories of the end right from the start. You're an obsession in my head, I can't forget your eyes. Your kisses burn my skin, I feel so empty inside.
So on YouTube, the soundtrack that I'm playing is actually copyright free on YouTube, which might not work on Twitch. I had to make sure that I got the copyright free soundtrack, because I don't want people pursuing me or chasing me with DMCA. DMCA sounds like YMCA. So I don't want folks chasing me with DMCA. So just a moment, I need to get my folder ready. So we can move on from there. Okay, so let me switch my scene. So folks, this what I'm going to do is sorry about that. So the way the transaction is implemented in Pulsar is that for the client is that we have transaction. Okay, so I think I need to zoom in so you guys can see it better. That means I need to change my scene. I don't want you guys to see my secret source. Yep. I don't think I have to see my secret sauce. So once I've enabled it, okay, so I can switch back. Okay, so the way that Pulsar implements that is at looking at the Apache Pulsar 2.0 implementation. I don't know if much have changed. I've not gone through it. That's why I'm doing a live um, review, a live implementation, or what we call it, a live pod. So I don't know if there's any changes from the way they implemented transaction client support for transaction in Apache Pulsar 2.7. So, but in 2.7, the way they actually did it was so. What you are seeing now is what you are seeing is it's made up of transaction builder, then exemption, then transaction coordinator client, and blah blah blah. So I don't know if any of this, the way they implemented it has changed. So in this streaming or in this session, for the next 1 hour, hopefully I'm able to implement because let me just read a maximum of 1.5 hours. So let's see any changes they've made in their implementation. So that was a good review. I think one of the benefits or one of the reasons I'm doing this is because I actually want to, I don't know, in the future, folks might really be interested in the way SharpPulsar was implemented, and maybe they probably watch this video, they can actually see how I went about implementing some of those, porting some of those codes from Java. So let's zoom from here. So I need to change my scene because I didn't. There's something I was supposed to open. I didn't open. Okay, so the first thing we're going to do is actually browse to the client folder. So I already know the structure of the folder. So let's look for transaction. This transaction buffer is not actually something that the client needs. I don't know because when I looked at it, some of the implementation there doesn't have to do with the client. I think the way they built the way they structured the source code, or the way they implemented Apache Pulsar is that given that at the back end, the broker also have what we call client as well. So most of those implementation at the client side, the broker client side we need, they also implemented it with the Pulsar client in general, umbrella terms. So the buffer handling is not actually something that, well, let's really take a look at it and see if it's something that we need. But when I checked it, last time I checked it, it wasn't something that we needed. It was actually something that was meant for the server side. So let's take a look at it. Only transaction and subscription. So one of the things I do is now for me to be sure if I actually need this. One of the things I do, and one reason why I work with Notepad++ is because one, for instance, I want to see where this is actually needed. So if this is not actually a C# program that I can just port into Visual Studio, though I think Visual Studio supports Java, but that's not the stress I'm willing to go through right now. So what I do is to actually find out if I actually need this on the client side. What I do is I find it. I try to find where it's being referenced. So what I do, that's what I like to find in files. I'll browse to Pulsar. So I go to the client. So what I do is I select the folder, I search for it. So now, okay, I can see. Let me zoom in. Okay, you can see that it's actually implemented. It's actually referenced in the client connection implementation. So the question now is, transaction buffer handler. Now the question now is on not on the broker client side, because there are two things. We have the user client side and we have the broker or the server client side, or you say the client side or the server client side. So now the question is, do you actually need this transaction buffer handler on the client side? So like I said, there's broker client side and the server client side and the client side. So let's just put it that. That means you actually need it at the level where users. Okay, so what I did was I was experiencing encoding overloaded on OBS. So because I put the frame rate at 60 frames per second, so I quickly stopped the streaming, because if there's much delay in the streaming, I think YouTube will terminate the stream. So I needed to do it quickly. So I've changed it to 30 seconds, 30 frames per second. So no more encoder overload anymore. So let's continue where we stopped. So now this is actually, let's look at this. Yes, for like I said, in my previous streaming, I mentioned using Akka as a building block for SharpPulsar, because the truth is, I think, okay, when do you need, that is the question now, is at what point do you actually need an actor? Let's answer that question. So the question is, at what point do you actually need to convert your code to an actor? So while I was implementing SharpPulsar in the first place, I needed to do a lot of locking. So for instance, so I think this is one of the, how will I call it now? One of the things to go through when you're actually considering using, because because we are dealing with multi-threaded applications, and you want to prevent, what will you call it now? You want to prevent corruption, because they call it data corruption, when multiple threads are accessing the same data. So if you actually use lock to actually prevent it, to make it okay, only a single thread can access this code per time. So this is one of the issues that I actually encountered while I was porting Java client. I was like, I had to, I think I had so many locks. I said, wow, these locks. And one thing about locks is that, according to what it says, that it degrades performance. So what I did that instead of me having to do this lock, why don't I just use an actor? Since an actor is serially, that is sequentially, processes messages and no two, or what will I call it, no two process or no two thread can access or process or use the same message at a given time, at any given time. So I said, okay, so let me save myself this headache because at the end of the day, it's all about my peace of mind. You get so even if I was able to write in such a way that okay, I implement lock efficiently, but in the future also, I always have to come back to issues that have to do with locking, threading, and all that. I think even in the official Java client, there are issues that I saw some posts, some issues that open around locking, around the unnecessary locks and all that. So I think I just cheated. I cheated with that is that for that. So let's move on. So let's look at the transaction aspect. So let's see what has changed. Let's compare. Transaction implementation. Tunu. Okay, so now what we have is transaction timeout. Let's see. Okay, not much has changed. But I'm sure this has to be different than the original implementation. So in terms of the constructor, nothing much has changed. So let's look at the implementation. Register partition map, register subscription map, client seek. We don't need all this. Client transaction, blah blah blah. Let's see if we actually have that. Register. Oh, I think there's something different. There's actually something different. There's actually something different in this version. So which has to do with addition map, subscription map. I think those two, which we didn't have. Let's see. Let's paste this. So we don't actually have this field in our current implementation. That means for this transaction, something has changed. So we are going to work on that now. The implementation has changed, which we are going to work on. So now to make it easier, now you see that we have a map. I think map is just refer to port it to C#. Map has to do with dictionary. Okay. So now I think there's another thing they've added again. Let me go native arc consumer. Okay, this is already there. It's already there, so I don't need to stress myself on that. So there's something I find. Okay, let me show you guys. You see this question mark. You see this. I don't know when You can have such in C sharp. This actually gives me a lot of headache. There is actually a current, there is actually an implementation right now that has to do with multi multi schema. That's where a consumer, a producer can have more than one schema, and it's actually really difficult. There is different kind of definitions. So I think in Java, it just make it easy for them. Another thing you can do is to convert this to object. Then in our case, we now need reflection. So I saw some write up on it. So I'll see how I can solve that problem without having to use reflection to actually solve my problem. But this is actually an headache. Seriously, this is actually an headache for us. Because if you are looking at the Java code and try to implement this is actually an headache. So let me escape from there and let me zoom out. So what we need to do now is, okay, like I said before, what I need to do is copy to save myself 80% of my time. So copy it. I need to close all this. You don't need this anymore. So let's copy our C sharp. What I'm going to do, in a normal day, what I can do is just copy this and paste it into. Okay, on a normal day, let's assume I'm writing this for the first time. What I'll do, I just copy, then paste it, then fix the errors. That's going to be a lot of work for me this time around. I think I've already fixed everything. What I need to do is just compare the differences to know where to focus or where to focus my effort on. Stashing. Talk about it later. So let's move on. So now what we need to do in our own implementation, is the only thing that is missing. Let me see. Okay, that's the only thing that is missing. So that means definitely the implementation also has changed. So what we do is copy it here. This complete table void. This has to do with task. But let's move on. Before I actually understand what to do with this, I need to see the rest of the code. Now, because we are using actor, all this is unnecessary for me. This has to do with synchronicity. This has to do with sending. I think that's one of the issues that I actually had, because the truth is, you send a message, for instance, then you add the task object to a collection, then you iterate over it to see if the task actually completed or not. So in your own case, in the Java client case, all they do when you send a message, you have to send the message as a task, you have to add the task to collection, then you have a background another thread pulling from the collection to see if the task actually completed or not. I think that's one of the way they actually did it was one of the issues that I had understanding that is just it. So this complete table just means task in C sharp. That's what it means. So that means they're talking about a tax that is void, something like that, and all that. So, but that's why I actually chose Aka.net actor because once I send the message, if it's actually successful or not, I will know. Now this comes with a challenge as well because the way the Apache Pulsar works is that once you send a message, you cannot send another message until the receipt. That is until the server acknowledges that they've received the message before you send another one. So that's one of the things I need to understand. That's one of the things I'm going to work on as well. So that you, well, thanks to Academy, I can always do something like I can change behavior. I can say on send become awaiting receipt. So with a timeout to get. So if I don't get a response from the server acknowledging the message I sent, then I can resend the message again. So I think that's where Java Pulsar works. You don't send another message until you see that there's an acknowledgement of the previous message that has been sent. That's how it works. So with Academy, I can always change the behavior. So let me wait. But let me sorry. So when I go to the producer, I'll look at that and see how you can actually because I've the Pulsar North America summit that they did recently when I was watching the video on there's a particular video session I was watching that when they talked about they're talking about they're talking about I think the sequence something that they have to mention that the client doesn't produce messages until it has received an acknowledgement from the server that the message that was sent previously has been received. So that's not what I've not actually paid attention to that, but after watching the video, I think it occurred to me that I needed to pay attention to that because now I have to make the code work as exactly even if I'm going to take my implementation in another approach with different design, but I also have to follow the original, how will I call it, principle or the original design, even if my own implementation is different. So when you get to the producer, you see how, if at all, I actually followed that or not. So, but in this session, I'm going to just look at the transaction aspect of it. So now we've already identified that okay, there are two things that was actually missing in our own in SharpPulsar implementation, which is registration for the subscription, the map that is dictionary, which registers the subscription, and the partition map as well, which wasn't there when I did this. So let's move on. What we are going to do now is look for this method. Let's see if we have it in our own. So we're going to look at the implementation, register map, compute, log this. See what I was talking about. See what I was talking about. This, sorry. So this is the problem I sought to solve with Aka.net. Now, what they are trying to say is that this block of code must not be accessed concurrently. That it can only be accessed at a time. So this is actually the problem that Aka.net actually solves for me. I would like to say I cheated with this. Well, that's part of it. That's part of the game. So you see the log there. So in let me show you. Let's look at the implementation. Let me move away from here. Escape. So let's go to implementation. Let's look for register topics. Let's register to let's look for register topics. It should be there. So this is it. See now, I don't need to actually bother myself unlocking this code because there's already a guarantee that once the actor receives these messages, there's no other thread or it's not being accessed by another thread. So there's no locking. I don't need lock. All I need to do is message pass it to pass message to the actor. You can see that the method there is private. You get. So that means the only way I can actually reach this code is actually to via message within the actor itself. So the burden of locking, the burden of having to monitor the lock, releasing the lock has been taken care of for me. So now, okay, let's go. Let's move on. And now this, let's move on. So let me see. Add partition. No, there's some changes. Compute. Return this. Compute. Let's see something. Producer topic. Oh, some things have changed. There's no more producer topic. Client add publish partition transaction. Add publish partition okay, let's look at what this thing. Okay, to transaction. Let me see if they've added new array. Okay, what is this? Then the topic. So all that means is they've actually changed this. I'm actually the issue of computing actually at times gets to me. I just wish I could just forget about it. So it is no more. Well, let's see producer topic. Okay. Oh, what they did was renaming. What they did was renaming. Okay, what they did was to rename. So that means what we need to do in our own code is also to rename. But at times it's always good to follow the implementation so that if there's any change in the future, you know where you you you, you know what to do. So in our own case now, what they did was to rename. There's no more called producer topic, but rather register partition map. So what I need to do is go back to where is it? So what I need to do, okay, I'm also sure this arc, what I need to do is to rename. Apply. So okay, so that means okay, there's actually okay, before I delete that. So this complete table is not necessary. So let's move on. So what they are saying is we should compute the topic. Hmm. I'm actually thinking about something. Why do they have this key here? Check it open, then compose. Okay, let's see this check it open. I need to check this method. Okay, check if open. Okay, check if open. Let's see if it's actually done. Okay, check if open is not done. So that means we need to get this. So now there's cool. So there's another update to it. The state. The state. State open. Okay, so new thing here. So so the question we need to ask now is this state, how is it being used? This state enumerable enum, how is it being used? That is the question we're going to ask, and that's what we're going to look for. So that means there's a state, there's a volatile. Well, a I'm not a multi-threaded low level guru. When I see words like volatile like that, it scares me. Like, what are these people talking about? Hmm. But I don't think that applies to us, does it? I don't know. If you're watching this video and you feel that it applies to my implementation, let me know. Okay, let's do this way. So let's look at volatile. Field in C sharp. Okay, so like you said, so it said the volatile keyword indicates that a key might be modified by multiple threads that are executing at the same time. The compiler, the runtime system, and even hardware may rearrange reads and write to memory location for performance reasons. Keys that are declared volatile are not subject to this optimization. I think the keyword is that indicates that a key might be modified by multiple threads. So the keyword is multiple threads. The keyword here is multiple threads. So I cheated because my transaction class is an actor. So that means it can't be modified. That is, the field will be private and cannot be modified by multiple thread. So I don't need volatile then, right? Yeah, I don't need volatile. Oh, I've changed my sorry about that. I've changed my scene. This keyword is this let me okay, let me change it again. Okay, so I need to disable that hotkey. It's actually making this the scene to change. So for those I was looking at the word volatile. What does it actually mean? So in regards to C sharp, and it says that it indicates that a field might be modified by multiple threads. So that proves that I don't actually need volatile uh, field since I'm using an actor, because the code won't be executed or be modified by multiple threads. So I can safely say, okay, that is not actually needed by us. So let me escape. So let me zoom in. So we don't need. What I was trying to say is, I was trying to know if we actually need. Let me. So what I was actually trying to look at was, do you actually need to make this state volatile? The answer is no, because it won't be changed, or it won't be accessed. So it's immutable, like they call it, like they say. So that means each instance of it running its own thread. So that means they don't need to. The code is how will I call it now? The code is self-contained. Let's put it that way. The code only you are running a process. You don't need to. You're not looking for access. What will I call it? If you see how easy I am right now,